Welcome CNG 132, or I'm sorry, 124. Do a quick follow-up on hexadecimal numbering and counting. I'm on my Surface, so it's going to be a lot different camera angle, along with a small picture of me in the corner. So let's see, when we're doing hexadecimal, I know a few of you said that in the reflective discussion that you had an issue with it. But remember that hexadecimal is only our 8 lines, 3, 4, 5, 6, 7, 8, our 8 lines, and then the values are 1, 2, 4, 8 twice. Excuse me. So here we have our byte, 1 byte in hexadecimal with our 1-bit value in that category. So when we look at the hexadecimal, we see a nibble on the left, a nibble on the right, and we have 1 byte in the center. When we go to counting anything, say we have F hexadecimal. So when I look at this value, I know that I'm looking at a hexadecimal value. FF, I know it's hexadecimal because I see this small h behind it. When I go to count, it's going to be 15. So I know that F is the farthest I can go. That means each one of these guys would have to be turned on. I guess I did that a little too quick. Let me go back here. The first nibble, let me go back to red. The first nibble right there is 11, or I'm sorry, 15. Is 15. So I designate that as 1, 1, 1, 1. Now to get that second value F, I have to do another 1, 1, 1, 1. And here we have the hexadecimal value. F is equal to 15. All these are turned on, and that's how I get to 15. Although it's not a binary number, I know that hexadecimal is there. So let's go back right there. So something I'd like you to look at would be 68. Does it equal 68 hex? You know, this is something we explored in class, and something you'll probably also see when you're out there. Let's use a different color. So let's figure out the 68 hex first. 8 does not go into 6, so we know we can't use 8. Shut that one off. Oh, let's go do a different color. Orange. Can't use the 8. The 4 does go into 6, so I can say, okay, we'll use that one. 2 goes into 6, but not the 1. When I go to the second part of the hexadecimal number, it has to equal 8, so I say we'll include this 8 here, and we'll not include the rest. So right there, my binary value, or my whole byte in hexadecimal is 0. In binary is 0, 1, 1, 0, 1, 0, 0, and that is the equivalent to 68 hex if we were to, where's my eraser? If we were to go back and say, does it equal, oops, I guess I can do this, pencil, blue, 16, oh, 32, 64, I think I messed up. 64, 128. Does this binary value equal 68 decimal? It does not. We can see that it's already 96 here plus another 8, 104. 104. So 68 hex has a binary value of 011010000. It has a decimal value of 104. So they're not equal. Important thing to figure out. When counting hex, always keep in mind we go from 0 to 9 in regular decimal numbers. When we go from values 10 to 15, we go through A to F. It can be a small a, it can be a large a, but either way, it's just going to be A through F. If keep practicing this part, ask people for numbers. You can ask people for numbers under 256. When we go back to that, let me see if I can't just get a new one. Menu, new, don't save. So even if they give you a value of 256, oops, can't have that. 254, because the only highest we can go in a byte is 255. So even if they give you any sort of value, we can say 254 would be 128, 64, 32, 16, 8, 4, and 2. So here's would be our byte value, our binary value, and then say in hex would be F, E, and then we can say it's a hex number, so it's 0xFE. Can work with any sort of number underneath 255, and it can also work with 0. Let's select a new one. Say we're given the value of 0. Then we say 1, 2, 3, 4, 5, 6, 7, 8, our binary value. Then when we move to hexadecimal, our hexadecimal value is 0, 0, H. So our first half and our last half have a value. That value is 0, and then we put 0, 0, H. So feel free to play around with this. Like I said, if you have people help you, give you a number under 255, that's the best exercise, because then it gives you a little bit to work on and helps you retain this a lot more.